Welcome to video 2, ladies and gentlemen, on rotating a figure. And we're going to start off doing it in a coordinate plane with this video. So if you remember, we ended this first video by talking about this quadrant and these numbers. We didn't number the quadrants, so let's go back and number them right now. So quadrant 1 right here is the positive positive. Quadrant 2 is the negative positive. Quadrant 3 is the negative negative. And quadrant 4 is the positive negative. Of course, reviewing, if we're turning clockwise, we're turning to the right and we're going around just like a clock hand does. And if we're going counterclockwise, we're moving left, we're going the opposite direction of a clock. And when we rotate 180 degrees, we are going to the opposite quadrant. What does that mean? That means the coordinate numbers are going to stay exactly the same, and it means the signs will be opposite. If I rotate 90 degrees, either direction, clockwise or counterclockwise, the coordinate numbers will switch. They'll replace each other, and then we assume the signs of the new quadrant. So let's take a look real quick. Let's just pretend for a second that I'm right here in quadrant 1. I'm in quadrant 1, and I rotate 90 degrees clockwise. So if I'm in quadrant 1 and I go clockwise, I'm going to be in quadrant 4. So the coordinate numbers would switch and the signs would be positive, negative, because that's the signs of quadrant 4. And of course, when we rotate 270 degrees, well, that's the same as rotating 90 degrees in the opposite direction. So let's just get busy. Ladies and gentlemen, you might want to put your pens and pencils down, everything down. Just watch, listen, and learn, and then pause the video when I'm done, and then pick up your stuff and write it all down while you're repeating it in your head. So unfortunately, I didn't label these, so we're going to label these real quickly. A, B, and C. So you want to write these down. A is -5, -1. B being -5 and -4. And C being -1, -4. I left some space underneath it so I could do it. Now, ladies and gentlemen, I'm going to show you in class how to physically do a rotation. We are going to do it mathematically with what we just learned on the previous slide. And we learned that if I'm going to rotate 180 degrees, we just learned that that's the opposite quadrant. Okay, and when we go to the opposite quadrant, what happens? The coordinate numbers stay the same and the signs will be opposite. So when I go to A prime, the coordinate numbers stay the same. So it'll be 5 and 1. But the signs will be opposite. So instead of -5, it's going to be +5. Instead of -1, it's going to be +1. And when I go to B prime, it's still 5 and 4. And the opposite of negative, negative is positive, positive. And when I go to C prime, I keep 1 and 4. And the opposite of negative, negative again is positive, positive. So now I'm going to go back to my coordinate grid and I'm going to graph these. So we're doing it mathematically first. I'm going to show you how to do it on your grid rotating in class tomorrow. So don't worry about that. All right, so A prime is 5, 1. I come over here, 5, 1, A prime. B prime is 5, 4. Go up here, B prime is 5, 4. And C prime is 1, 4. And I go 1, 4, C prime. And of course, you will use your straight edge so that you autograph your work with excellence and that you use precision. And there would be the rotated figure 180 degrees. It is exactly opposite. Notice very quickly that point B, the original B, is that far from the origin. Well, it's exactly opposite. I can keep going with that straight line and go right to point B. It's exactly opposite. 180 degrees is exactly opposite. And I can do that for A, and I can do that for C. They all go through the origin. They're all the same distance from the point center of rotation. They are exactly opposite. The signs are opposite. Everything about 180 degrees is opposite, except the coordinate numbers. The coordinate numbers are the same. Okay, so that's a 180 degree rotation. You might want to pause the video, write all that down. Go. Welcome to example number 4, where we're now going to rotate the figure 90 degrees clockwise. Make sure you put your stuff down. We're going to go 90 degree clockwise, and I'm going to put down my original figure, A, B, and C, and I'm going to write that down. A is -5, -1. B is -5, -4, and C is -1, -4. And since I'm going to rotate clockwise, I love to mark my paper. So I'm going to take this clockwise, going like a clock. That means I'm going this direction. And when I go 90 degrees in that direction, I'm going from quadrant 3, and I'm rotating up to quadrant 2. I know my signs in quadrant 2 are negative, positive. So I know my signs are going to be negative, positive. And when I rotate 90 degrees in either direction, what happens to the coordinates? That's right. They are going to switch. So when I go 90 degrees this direction, they are going to be negative, positive, and we're going to switch. So A prime, instead of 5, 1, it's going to be 1, 5. And I know quadrant 2 is negative, positive. So negative 1, positive 5. B prime, they're going to switch, so it's 4, 5. And I know I'm going to quadrant 2, so again, it's negative 4, positive 5. And again, C prime, the numbers are going to switch. The coordinate numbers to 4, 1, and I know that quadrant 2 is negative, positive, so negative 4, positive 1. I come over here and I graph my new figure. Negative 1, 5 for A, negative 1, 5, boom. Here's A prime. B prime is negative 4, 5, up here, B prime. And C prime is negative 4, 1. C prime, and of course, as we always do, using our straight edge to autograph our work with excellence. Ladies and gentlemen, notice if I were to use my straight edge and I drew that line, let's say from C, if I drew from point C to the origin, and then I drew it from the origin, because that's our center of rotation, to C prime, I would have a 90-degree angle of rotation there. And each one of those points is the same distance from that center of rotation. So go ahead and pause your video. Write all that down, repeating it in your head as you do, and join me for example 5. Welcome to example 5, where we're going to rotate, this time 90 degrees counterclockwise. So we're going to go 90 degrees counterclockwise this time. And we have A, B, and C. So we have A, which is negative 5, negative 1. B, which is negative 5, negative 4. And C, which is negative 1, negative 4. And I am going to rotate this time 90 degrees counterclockwise, so I'm going from quadrant 3 to quadrant 4, and I know quadrant 4 is positive, negative. So that's what my signs are going to be. And I know when I do 90-degree rotation, my coordinate numbers switch. So A prime, again, is going to be switching from 5, 1 to 1, 5. And I know quadrant 4 is positive, negative, so it's going to be positive 1, negative 5. B prime, the coordinate numbers switch to 4, 5, and I know we're positive, negative, so it's positive 4, negative 5. And C prime switches to 4, 1, and I know again we're positive, negative, so it's positive 4, negative 1 for C prime. Then I can come over to my coordinate grid and plot those points. A prime is 1, negative 5, A prime. B prime is 4, negative 5, B prime. And C prime is 4, negative 1. And of course, using your straight edge, drawing that nice precisional figure. And then once again, if you were to use your straight edge, just to check it out, if I have point B on my original figure and I draw a line to the center of rotation, which is the origin, and then I draw it to the B prime, I would recognize that that is a 90-degree angle of rotation, and that B and B prime are the same distance from the center of rotation. All right, so go ahead and pause the video and copy all that down and join me for example number 6. And here's example 6, where this time we are going to rotate 270 degrees. And what do we know about a 270-degree rotation? That's right, referring back to our first slide, the one we finished an example in our first video. We know that 270 is the same as a 90-degree rotation in the opposite direction. So let's figure out why that is. So here I am in quadrant 3. And I'm going to go 270 degrees counterclockwise. So if I go 90 degrees, that takes us to quadrant 4. And then I go another 9 degrees for 180. This is 90. This is 180. Now I'm in quadrant 1. Oops, quadrant 1. And then I go another 9 degrees, so 180 plus 90, that is 270 degrees, and I end up in quadrant 3. Well, if I end up in quadrant 3, is that not the same as a 90-degree rotation, the opposite direction of clockwise? That is correct, and that's why it's the same. So ladies and gentlemen, again, let's write down our original figure points. A is at -5, -1. B is at -5, -4. And C is at -1, -4. And of course, we're going to treat this 270-degree counterclockwise rotation as a 90-degree clockwise rotation. And we know when we rotate clockwise, what happens to those coordinates? That's right, they switch. So we go to 1 and 5. And we know the coordinates of 3, when we rotate 90 degrees this direction, is going to be negative positive. So that's -1, +5. B prime, the coordinates switch, and it's negative positive, so -4, +5. And C prime, again, they switch to 4, 1, and we know it's -4 and +1. So we're going to go back. We're going to go -1, 5, A prime. We're going to go -4, 5, B prime. And we're going to go -4, 1, C prime, drawing with precision, making our new figure, and that would be the thing. Again, I will be showing you how to do this in class without doing it mathematically. I'm going to be giving you, you're going to actually perform a physical rotation without doing it mathematically, and we'll use our mathematics to check this. So ladies and gentlemen, if you'll notice, this matches up with example 4. It's the same location example 4, because in example 4 we went 90 degrees clockwise, and you'll see it matches up. But this one was 90, 180, oops, and then 270 degrees counterclockwise. All right, one more example, ladies and gentlemen. Go ahead and pause, write this down, and join me for our last example of the night. And welcome to our last example of the night. We're going to do multiple transformations. The first thing we're going to do is reflect in the x-axis, and then we're going to rotate the image 9 degrees counterclockwise about the origin, and we're going to define the new image location. So I'm going to start off right here. We're going to reflect the triangle in the x-axis, and if you recall from reflections, what do I always do? That's right, I highlight my line of reflection. I'm going to write down the original coordinates right here. So we have J, and J is at -4, 2. We have K, oops, I didn't want to do it in that color, my bad. I'm going to erase that. I'm going to put it in black for my original. So J is -4, 2. K is at -3, 2. And L is located at -3, 4. And so now I'm going to do my reflection, and with red, I'm going to reflect over the x-axis. So I'm going from quadrant 3, from quadrant 2, I was thinking about where I was ending up, to quadrant 3. And all points are the same distance. So when I reflect, I'm coming with K down here to -3, -2. With J, I'm coming down to -4, -2. And with L, I'm coming all the way down 4 units below L prime. And then I'm writing down my new location. So J prime is now going to be -4, -2. K prime is -3 and -2. And L prime is still -3 because we reflected over the x. Remember, all the x's stayed the same. That is true. And the y went opposite, so -4 for L prime. Well, we're not done yet. We're going to do one more transformation, and we're going to rotate 90 degrees, and it says counterclockwise. So if I come to I mark my text, counterclockwise says from quadrant 3 to quadrant 4, and I know quadrant 4 is positive, negative. And we just learned, when we do a 90-degree rotation either direction, the coordinate numbers switch. So J prime prime this time, we're going to be 2, 4, because they're going to switch. Boom, boom. Just like that. And we know we're going positive, negative. So it's +2, -4. K prime prime. 2 and 3, we're going positive, negative. And then L prime prime, 4 and 3. And we're going positive, negative for L prime prime to 4, -3. So again, we're going to mark our new figure location. So J prime prime is at 2, -4. J prime prime. K prime prime is 2, -3. K prime prime. And L prime prime is 4, negative 3. And when we do that mathematically, we are in our final location, and there's our coordinates. So doing multiple transformations, ladies and gentlemen, not difficult. We just follow all the rules we've learned about doing transformations. Ladies and gentlemen, again, I will show you how to do rotations in class. Don't fret it. We learned how to do it mathematically, and you have this quick right. Finish this quick right. You're done tonight. Draw the image of the figure after a 90-degree rotation clockwise about the origin, and of course, write down your final image location. Ladies and gentlemen, thank you for sharing your time with me tonight. I know you learned something, and we'll talk about it tomorrow. Thank you.